This is Modumath 3.6. The subject is changing fractions to decimals and changing decimals to fractions. Modumath text 3.6 goes with the tape. Open to this text now. Keep pencil and paper handy to solve problems and take notes. If you have any questions about the material or the machine, ask someone to help you. While decimal fractions have lots of important mathematical uses, we are interested in them chiefly as a substitute for fractions. They have at least two advantages over fractions. They're much easier to add, subtract, and compare. And they fit in better with our system of decimal notation. Well, we've learned to work with decimals, so all that's left is this important last step, changing back and forth between decimals and fractions. Changing decimals to fractions is pretty simple. Let's not worry about the whole number part of the decimal. That part stays the same anyway. We know that if a decimal has one digit to the right of the decimal point, we can think of it as a fraction with a denominator of 10. For example, 0.3 is just another way of writing the fraction 3 over 10. 0.8 is 8/10. 7.5 is 7 and 5 over 10, and so on. If a decimal has two digits to the right of the decimal point, we can think of it as a fraction with a denominator of 100. For example, 0.24 is 24 over 100. 18.07 is like 18 and 7/100ths. Just to make sure you understand this, take time to write each of the following decimals as a fraction. Here are the answers. 0.19 is another way of writing 19 over 100. 0.006 is 6 over 1,000. 3.98 is 3 and 98/100ths. There are more problems like this worked out in your Modumath text. If you're having any trouble, go over them. Otherwise, you're ready to go ahead. Changing fractions to decimals is quite different. Let's take an example. Here's the fraction 4/7. We can think of this as an order to divide. So let's write it as a division problem. 4 divided by 7. Put a decimal point after the 4, and put a second one directly over the first in the answer. Now comes the question that always comes first in dividing decimals. How accurate do we want the answer? Do we want it accurate to 1 decimal place? 2 decimal places? 3? Suppose we want 4/7 accurate to 2 decimal places. Then we'll need at least 2 decimal places in the quotient. But actually, we'll need one more than that, because if we need to round off, we'll have to know the digit in the 3rd place. So, to give us 3 places, we write in 3 zeros after the 4. Now we start to divide in the usual way. Carried out to 3 decimal places, the work looks like this. Rounded off, it's 0.57, or 57/100ths, and that's it. 4/7 accurate to 2 decimal places is 57/100ths. Notice we didn't worry about whether the quotient is a terminating decimal or a repeating decimal, or if it's a repeating decimal, how big the repeat might be. We concentrated on the number of decimal places we needed in our answer. Suppose we want the answer accurate to 3 decimal places. We write in 4 zeros as shown. Carrying out the division, one more step, we get 0.5714. 4/7, accurate to 3 decimal places, is 571 thousandths. As it happens, when we divide by 7, the quotient is a repeating decimal, and the repeat is fairly long, 6 digits. Sometimes the repeat is much shorter, and we discover it right away even though we weren't looking for it. Suppose, for example, we try changing 2/3 to a decimal, accurate to 3 decimal places. We write the fraction as a division problem. Place the decimal points, write in some zeros, 4 this time because we want the answer correct to 3 decimal places, and start dividing. The first digit of the quotient is a 6. 6 times 3 is 18. 20 minus 18 is 2. Bring down the first 0. Second digit of the quotient is also a 6. Repeat the process. Third digit is a 6. So is the fourth and the fifth, and so on indefinitely. We can round this off to 3 decimal places as shown. 2/3, correct to 3 decimal places, is 0.667, or 667 thousandths. But sometimes we write it as decimal point 6 with a little bar over the 6. The bar means this much forms a repeating pattern. Actually, this form is more accurate than the first. The rounded answer, decimal point 667, tells us nothing about what happens after the 3rd decimal place. But the answer, decimal point 6 bar, assures us that wherever we look in the quotient, whether it's the 3rd decimal place or the 30th or the 300th, we'll have 6's right down the line. Here's another example. Let's compute 3/11ths accurate to 3 decimal places. Set up the problem. Place the decimal points. 3 decimal places means 4 zeros. And we start to work. The first digit of the quotient is a 2. Then a 7. Another 2. Another 7. That does it. Again, we've discovered the repeating pattern, even without meaning to. It's 2, 7. So we can round off our answer as originally instructed. Decimal point 2727, correct to 3 decimal places, is 0.273, or 273 thousandths. So far, we've considered only repeating decimals. But sometimes the answer is a terminating decimal. That is, it comes out even sooner or later. Here are a couple that terminate after only 1 step. You are probably familiar with them. The fraction 1/2 is equal to the decimal fraction 0.5, or 5/10. The fraction 1/5 is equal to the decimal fraction 0.2, or 2/10. Now let's change 1/4 to a decimal fraction. First, write it as a division problem. Then, place the decimal points, write in some zeros, 3 should be enough, and you take it from here. If your work is correct, this is the answer, 25 hundredths. If you got anything else, check for careless mistakes or ask someone to help you. Of course, any fraction at all can be changed to its decimal form. Here, for example, is a problem from your Modumath text. Change 5/12 to a decimal, correct to 3 decimal places. The method is always the same. Rewrite the fraction as a division problem. Place the decimal points in dividend and quotient. Write in zeros, 4 in this case, since we're asked to give the answer accurate to 3 places. And from there on, it's just an ordinary division problem. You can finish it yourself later on. It's a good idea to learn the decimal equivalents of the fractions we work with most often, 1/2 and 1/3 and so on. Here we've shown some of them in a table. It also appears in your Modumath text as Figure 1. We've written in the results found earlier. Work out the rest yourself when you're done with the tape. You needn't exactly memorize these decimals, but get used to them. You may be working with them a lot. Let's review the important ideas of this tape. We began by recalling that one big reason for studying decimals is as a substitute for fractions. So it's important to be able to change from one to the other. Changing a decimal to a fraction is easy. All we do is rewrite it with a denominator of 10, 100, 1,000, or whatever the right power of 10 may be. As for the reverse, changing a fraction to a decimal, we simply think of the fraction as an order to divide, decide ahead of time how accurate we want the answer to be, and go ahead as with any problem in the division of decimals. The quotient may be a repeating decimal or a terminating decimal. Sometimes we don't even bother to find out. Finally, we suggested that you get used to the decimal forms of fractions we use most: 1/2, 1/3, 1/4, and so on. If you had any difficulty with the ideas of this tape, replay the tape or ask someone to help you. Otherwise, you're ready for the problems in your Modumath text.